here and whether we can get the session started. But in any case, we're going to get going in a couple of minutes because I think I see on the camera that we've got a good number of people coming in. Okay, we're a minute past the hour, and I think we have a lot to cover today. So let's get into it. So welcome everybody to the first of two more instant messaging interoperability sessions we'll be having this week during this IETF plenary session. First off, as usual, we'd like to remind everybody to note well the note well, in particular IETF's policies on intellectual property and the code of conduct that that you've already agreed to by attending this meeting. Before we look at the agenda, would anybody like to volunteer to take notes for today's session?
Yes. Somebody got voluntold. Somebody without a laptop got voluntold to take notes. Okay. Can you sit up here? You can sit there. Yeah, it's okay. It's not like a big duty. You don't have to sit up here. Everybody's staring at you for an hour and a half. What's your name? Sorry?
Yeah, can we get it?
Connor. Connor is our note taker. Thank you very much, Connor.
Thanks, Connor. Sincerely appreciated. Okay, now let's look at the agenda for our two sessions. So today in session one, we have Administrivia, which we're covering right now. Then Richard Barnes is going to give us an update on MIMI protocol. That document and the architecture document have been adopted by the working group since the last time we met in a plenary, so lots of new stuff there. Then Rowan Mayhe's going to do an update on the content format draft. And then we're going to have a couple of presentations on the question of metadata privacy from Conrad Kobrock and then Brendan McMillian. The second session, which is later this week on Thursday, will be focused on user discovery requirements, and then we'll talk about room policy some. So do we have any changes or additions to today's agenda? Oh, sounds like we're okay. Oh, Conrad, go ahead.
Sorry, yeah, I just want to note, might make more sense for Brendan to speak first about his approach and then me talking about the feature stuff.
Okay. Brendan's not in the participant list. Perhaps they're still on their way, or...
Okay.
Brendan, are you in the room?
I mean, I can go first if he's not here, but yeah. Okay, thanks.
Okay, well, I guess we'll see when we get there, right? Actually, speaking of people being here, Richard's first up on the agenda, but I don't see Richard in the participant list.
Yeah,
he's in the room? Okay. Richard, are you ready?
You can sign into Meet Echo after, maybe.
Hello.
Oh, actually, wait, do we want to deal with this?
Oh, let's do that at the end of day 2. Yeah.
Okay. All right. Richard, I'm going to throw up your slides. Whoops. There we go. Take it away, Richard.
All right, cool. So this is going to cover the architecture document just real quick because there's not really any news there, and the protocol document. The only real news with the architecture document is now draft IETF because we adopted it last time. Round of applause for working group progress. Yeah. Is there a clicker here or should I just shove it in? Let's see.
That works.
But, since a lot of folks weren't on the interim meetings or haven't seen this in 3 months, 4 months, figured it would be good to refresh people's memory on the architecture we have here and what we're talking about. Is this working?
But I don't know that it'll work because it's all being run through Meetup anyway. So.
Not working.
Yeah.
All right, so Tim, could you hit the next slide, please? So just to remind people, this is my favorite bit of terminology in Mimi. We have a client to server to server to server to client architecture. So if you're a client, you have a local server you talk to. The meeting is hosted on a server, which we call the hub, which may be a different server. And the other people on the other side of the meeting have their own local server through which you reach them. So everything kind of gets routed through those 3 servers. And the organizing concept is this room thing. Next slide, please. So it's just more of what I just said on the last one. Next slide. Yeah, so the organizing unit of functionality here is a room. And this is exactly the concept you think it is. Like it's a space that has a bunch of users where we're exchanging messages, posting files, sharing emojis, things like that. In this, we're going to talk less about the actual messaging and more about the metadata and the functionality, because Rowan's got a nice content document that defines how you actually do the fun stuff that you want to do with the room. But we as the working group need to define all the boring stuff, like how we decide who gets into the room, how everyone knows who is in the room, and things like that. So we have a set of state attributes associated to a room, an authorization policy, a participant list, and a list of clients who are members. So we have two levels of membership. Users are participants, right? So users are like people like Connor or Britta, and then clients are devices like Connor's laptop or Britta's phone, right? So those are members. So we have 2 different notions of membership. And that becomes salient because the participant list is managed at kind of the Mimi layer. The client list, the specific devices that are involved, that gets managed at the MLS layer. That's where the end-to-end security attaches. So yeah, how those 2 relate to each other is a lot of where the subtlety comes in, and I'll talk about in just a second. I'll skip over the last one because it's not super salient. Next slide, please. So this is just kind of putting that kind of layered notion in a figure, because it's useful to think of how these 3 are like. So on the left-hand side, we have the policy that governs who can be in a room and what they can do. In the middle, we have that participant list, which is at the user level. And on the right-hand side, we have the very specific list of clients, those individual devices. Next slide, please. What? Capabilities. Thank you. So there's a couple of principles in the design here. One is this policy of preemption, that the authorization policy governs the participant list governs which devices are in the room, right? So you can only have a device in the room if you're a member on the participant list. You can only be a member on the participant list if you are allowed by the authorization policy, right? Make sense? Next slide, please. There's also this idea that we want of confirmation. So MLS, our end-to-end security layer, provides this property that it can confirm that all of the devices in a conversation have the same view of a thing. And so we would really like to confirm that all of the devices in the conversation have the same view of the participant list and the authorization policy, so that we all have a coherent view of what's going on in the room. So there's kind of this back and forth dance where the policy governs the participant list, which governs the MLS group, but then the MLS group kind of reaches back and confirms that we all agree on all that other stuff. Next slide, please.
You have Mary in the queue. You want to take questions?
Oh, sorry. Yeah, I can't actually see the queue. So
yeah. Mary, do you have a question? Oh, okay.
maybe I can see the queue. Mary just wasn't there. All right. Next slide, please. Oh, thank you. Yeah, so this kind of interrelationship between those 2 directions causes a little bit of delicacy in how exactly we run the protocol, because you need to kind of propose changes to the policy or to the participant list, and then those need to get committed quickly so that that confirmation property applies, and you get confirmation that everyone agrees on the changes. Next slide. All right, that's your 3-minute 4-minute architectural overview of Mimi. That's kind of as far, it gives you the big picture of how this is all supposed to fit together. Let's dive into a little bit of the protocol bits and how this mechanically fits together a little bit more. This is also in draft IETF. Round of applause for working group progress. All right, and this one we actually have a little bit more, we've done a little bit more work at some of the interims between the last meeting and here. So we'll cover those as well. So next slide, please. So you may remember a few slides ago, I talked about the client to server to server to server to client architecture. I always have to count in my mind when I do that. And this gives a little bit more detail. So basically the arrangement we have here is that the room is attached to a hub server. So each room lives on one server, logical server, represents a provider. The other servers that may represent users or clients who are not with that, the hub provider are, we call them follower servers. I guess maybe we have a terminology alignment problem, spokes or leaders. But this is the terminology we have right now. So we then have interactions using HTTP requests. So this is showing something like a messaging interaction where a user on this side of the follower has sent in a message for that follower provider to deliver. The follower provider sends the submit request out to the hub, and the hub fans it out to everybody else. The other little subtlety here is that the hub maintains a queue of MLS proposals, this is related to that interaction between preemption and confirmation we were talking about, where sometimes some things need to get queued up and proposed in MLS before they can get committed. And so the hub kind of tracks those and causes clients to then commit them at the right times. Next slide, please. Server to server communication, it's all HTTPS. We assume that providers are identified by domain names. So you have provider.a.com, provider.b.com, and then we just use regular old web PKI mutually authenticated TLS server to server. It's a presumption nowadays. We could iterate on this if we want, but nothing really surprising here. I think the main ambiguity is where that little construction worker sign is. Like, how do you identify, and when you call out to a server, when you make an HTTP request to a server, you specify the identity of the server in the host header among the potentially many in the certificate. There's not really a way to do that for the client side. So you can send a client certificate, but HTTP doesn't really have a way for a client to say, this is the identity I'm representing in this interaction. So we may need another HTTP header from that. We've used from right now. It's not really right, but it's not a difficult thing to fix. Next slide, please. So this is where it starts to get cool. So MLS, like I said, has this group agreement property, but you need to kind of feed stuff into MLS if you want to confirm that you all agree on it. And so Rowan and I defined this AppSync protocol, which is an extension to MLS that lets an application use MLS to synchronize some state. So the state, some blob of state that the application has provided gets incorporated into the MLS state that everyone confirms they agree on. And then we can use the MLS proposal machinery to make updates to that state. As a result of that, we end up using MLS for a few things. So we do, the first two are kind of the stuff you agree, you would expect MLS to be used for. We use it for end-to-end encrypting messages. We use it for controlling which devices can send and receive messages, who has the end-to-end encryption keys. But then that third thing is we use this AppSync extension to synchronize state. And so the state we end up synchronizing here is those two, if you think of that 3-column diagram, we synchronize information about the participant list and information about the room policy. And what that means, but by virtue of the fact that we're feeding all this into MLS, is that if my client and Connor's client and Britta's client are all in a conversation together, we all agree on who's allowed to be here and who is here right now. That all makes sense. I'm glad JDR is nodding along here. Next slide, please. So policy and participant list, this is like real hard hat area. I think Rowan has some more concrete thoughts on how to express this later. There's been a lot of iteration on this we need to kind of start working into PRs. But the idea is that, oh yeah, Rowan, go ahead.
Yeah, there's agenda time on Thursday for room policy.
Yeah, excellent. So what's in here right now is sort of a capability-based framework. the idea is you have identifiers for things like rooms and users, and then you assign roles to the participants in those rooms. As Rowan said, we have time on Thursday. This is very likely to change, but this is what's in there now. Next slide, please. Finally, these are the interactions we've got defined right now that can happen among the servers in the current document. So you start, if you've seen Acme with the Acme directory, this might be familiar to you. You start with a directory that tells you where all the endpoints are that you talk to do things on a given provider. To add someone to a room, you first fetch key material for them. In MLS, this is a key package that you use to bootstrap someone into the end-to-end security. And then to make changes to a room, you submit these updates to add someone to the participant list or to add a device for them. To do actual messaging, you have a submit message, which you send to the hub. Oh, sorry, this notation on the left is follower and hub for FNH, right? So these interactions with key material and with updates are all either transiting the hub in the case of key material or going to the hub to make updates to the room. Likewise, submitting messages, the follower server representing the user sending the message uses the submit endpoint to send that to the hub, and then the hub uses the notification endpoint to fan that out to the other follower servers. The group info endpoint is another kind of information about the room endpoint that tells you how you can add a new device to this to the MLS group asynchronously of all the other participants. So again, this is probably highly likely to change, but this is where we are right now. And hopefully you can kind of see how this basic set of interactions gets you toward something like the messaging interaction you would expect to be able to create with this. Next slide, please. All right, so that is getting you up to today. So we have fast forwarded through the last 4 months, and now we are at IETF. Well, we're here. So actually, not quite there. We're going to go through the PRs we've done here in the last few months. So we had some interim meetings. Next slide, please, Tim. Had some interim meetings to try and agree on some changes to this after we adopted it. First PR we merged was to change it from draft whatever it was to draft IETF. So once again, a round of applause for working group progress. Thank you. Didn't expect that to actually happen. Again, another kind of housekeeping one we just merged is to take the AppSync stuff. We'd originally written it up as a section of the MIME spec. We moved it out to a document in the MLS working group, just housekeeping. More interesting technical stuff. We added a kind of internal identifier resolution function. Actually, Rowan, would you mind explaining this real quick? Because I'm forgetting the details.
Sure. Yeah. So the idea is that, I mean, basically when you would use this is you have a handle, but there is an identifier that's actually used. Maybe it's like a UUID that is actually used internally. And so you need to take the handle and say, okay, I've got a handle at this provider, give me the internal identifier. And then that's the thing that you use in everything else.
So this is like your wire handle might be the public thing you want to resolve. That's some internal identifier
Exactly.
you use for action actions. Yeah. So think about whether this is, if you're with a messaging provider, think about whether this is salient here as, or whether you have more public stuff. The other thing we added was a very basic consent mechanisms, right? In messaging systems, right? Not everyone wants to be contacted. Not everyone wants to be added to rooms. You have limitations on those sort of things. And so we added a mechanism by which someone wanting to add someone to a room can make that request to get the other person's consent to add them to a conversation and then receive either a specific grant of consent for that one thing or a broader grant that says, it's fine, just you can add me to whatever, I'm happy to be generally connected with you. So it's a very baseline thing we've got in there now. I think that's something we'll probably iterate on, but I'd be interested, especially folks who have trust and safety experience, how that looks. Finally, we had a bunch of discussion, and only recently, I don't think we have PRs here, but we've got a couple drafts we'll talk about later in the agenda about how we handle kind of metadata privacy and invalid commits and things like that. Bunch of good discussion in the interims, but didn't have any PRs, so nothing merged right now. So these are the PRs we've merged. I think the next chunk I have is on things that are still open. Next, yeah, so next slide, please. So we've got, I think, 4 PRs that are open at the moment. one about downloading files, abuse reporting, and then a couple of approaches to this metadata privacy question that I mentioned on the previous slide. So I think I've got a couple notes on each of these in the next couple slides. Next slide, please, Tim. So on the downloading files thing, like I think everyone in the room probably knows, the general pattern that every messaging app in the world follows is upload a file to some, encrypt the file, upload it to some server, and then in the messaging system, you send a link to the file and the key to decrypt it with, right? So that is obviously the pattern we're going to apply here. It gets a little complicated in the federated case here. We have this practical concern about who's actually going to store the files, was it the hub server or the followers, and how do you access control in those situations. There's also a privacy concern around this in that wherever the file is hosted, that person can see who downloads it, and that leaks information about, say, who's in a group to someone who might not otherwise have that information. It leaks things like IP addresses, absent things like oblivious HTTP. So I think the PR that's up there right now provides a proxy download functionality where someone can ask a server to download a file on their behalf. It's kind of like the same sort of thing, same sort of indirection you would do with oblivious HTTP, but done at the application layer. I think it's a starting point. It's a PR, so feedback welcome. But the idea is to kind of try and address that privacy question by indirecting it, just like you would with something like HTTP. Next slide, please. And happy to have discussion if anyone has thoughts. JDR, I see you making concerned faces. Yeah, go ahead. Yeah, this is the more discussion oriented because this is still, still stuff that's open.
Jonathan Rosenberg, 5'9". First, I apologize. I've been out for a little, so I may have missed some discussion on this. So feel free to sit down. We already discussed this. I understand the general file upload download pattern, but why does the file system have to be outside of the hub at all? This problem's about leaking of information happens when it exists as a separate entity, but practically speaking, it won't. The hub is not like a server, it's a giant service, right? So doesn't all these problems go away if we just make this some more interfaces on the hub?
It could be. I think Rowan has comment, yeah.
Hi, Rowan May. So a pattern with, there are not that many federated systems, but the federated systems that exist, they have one of two patterns. The sort of plurality of them upload to the sender's server, and a handful of them upload to the sort of owner's, the hub, what would be the equivalent of the hub. But in either case, the idea is that maybe you trust some large provider to be the host of this system where all they see are a bunch of pseudonyms, but you don't trust them to know when a particular IP address downloads something, because that leaks private information about that user who has no other direct IP connection to the hub.
Right, so to say that differently, in the MIME interactions, all the interactions are indirected through the follower server. And well, so that's actually what this PR does. It indirects
does
the
exactly
download
that.
through the follower server. So I actually think it's compatible with what you're talking about, JDR.
Ben Schwartz, Meta. Although I don't work on chat systems, so I claim no expertise. So
I assume whatever you talk about is binding on
Too
WhatsApp.
bad.
So I have real difficulty imagining that any of these servers are going to want to act as reverse proxies out to arbitrary origins on the internet to download random files. So I think that seems like not a deployable architecture. Presumably these files need to be effectively hosted on one of the participating servers, presumably the follower affiliated with the user who did the upload. Because I, as a hub server, I'm not going to let you, random user with whom I have no business relationship, post a gigabyte of data that I have to store forever. And I like the idea of proxy download. I do think it would be helpful if we could be careful to do that in a way that permits streaming so that I can potentially still be uploading the file while you're downloading it. Because otherwise we're creating a tandem delay effect where I upload the file to my server and then it has to be, and only when that is complete can you potentially download it. And then for you to download it, it has to be, in some designs, transferred in whole to your server or maybe to the hub and then to your server. And so we're creating a performance issue there.
Yeah. Well, so good. I appreciate that Ben and Jonathan have both articulated support for the very two models that Rowan mentioned. So, I mean, actually, if we could scope this down to those two models, like we could maybe have a thing where you could negotiate it at runtime. Like if the file either lives on the sender's follower server or on the hub, like you have to design a way to fetch from another follower server or from the hub, but that's not a difficult thing to negotiate.
I'm not 100% sure that there's a distinction if these are caching proxies.
Although, I mean, if the hub
But
is caching,
can you come back?
then
I thought you just made the distinction about someone else not wanting to download from an arbitrary user server. So isn't
So
that the distinction?
So my expectation is that if there's a long-term, essentially permanent home for the item, that kind of has to be the follower's server. That's my expectation. But that doesn't mean that every download has to go all the way, be proxied all the way back to the follower's server. If these are caching proxies along the way, then it could also be for a substantial amount of time sitting at the hub server and effectively served from there.
so you're making a distinction between permanent storage and temporary cache storage. Fair.
Raphael is next.
Hi, Robert from Phoenix R&D. I just wanted to note that we do have a draft for that called MIMI attachments. We've had it for a while, and we never really proposed it for discussion so far because at the time it felt like it was still far out to talk about that. So it doesn't really go into the whole question of proxying or not. I think the underlying assumption was that files would be on the hub indeed well, I think mostly for privacy reasons. And also because since the hub is the one managing resources anyway, it seemed a natural choice to do that. And it also covers the question of access control in that instance and how the file should actually be encrypted. So long story short, of course, the idea was never for it to be a standalone document. It should probably be merged into a MIMI protocol at some point. So yeah, just want to throw that in the ring.
Thank you.
Bingo.
Hey, I'm Ben. So let's see. My first question is about something Jonathan said about like hubs will only ever be big. Is that like a goal or requirement of the architecture? Okay. And then, yeah, second off, I guess I just want to voice support for the idea of letting data be not at the hub because it seems like it could lower the cost of operating a MIMI provider by letting providers cooperate and coordinate and share the data hub. So +1 for that.
Cool, thanks. Jonathan, next.
Hey, yeah, I just thinking about this architecturally. Normally, in the architecture, the first S and the third S in the CSSC never talk to each other. Is the intention, directly? They only talk to each other through the hub. Does that apply in this case also? Because that would require more proxying, but might be easier both from a. I don't know how to what extent server, remote followers are considered private from other followers, servers.
Yeah, I think one of the slides I skipped past kind of quickly in the architecture discussion was there was a principle in there that all of the communication is via the hub. You don't presume that followers will talk to each other directly.
So if the file was on the originating proxy, originating server, that's have to be a double proxy.
Yeah.
Okay.
Which, if you stream it right, might not add much latency.
Jonathan Rosenberg, to be clear, like you say everything goes to the hub, but actually the consent requests are follower to follower. It's inconsistent in the architecture. So
Fair, fair.
I was going to comment like, yeah, you've been standing up here like lying for like an hour about that. It's like completely wrong. Even the acronym is wrong. All right. So I think there's actually 3 orthogonal design decisions, and I think they're actually orthogonal from each other. The first question is the transference of the file through the MIME protocol itself? The second question is it, sorry, I thought I had it 3 and then I came up here and now I'm down to 2 in my brain. Is it through the MIME protocol? Is the file stored at the follower or the hub? I thought there was a third, but maybe there's 2. So I think we can sort of make separate decisions on those different things. Yeah. I'm of the opinion that I think the harder one is whether it's on the hub or the follower. I'm actually of the opinion that it's on the hub, not the follower. And the reason is like, is there really a difference between a big message and a big file? We're already storing big messages on the hub. We already say that the authorization decisions, policies are on the hub. So if there's a decision for like how long this content lives, that would be an interesting piece of authorization policy. It often is, right? Like in Slack, it says, your messages will be persisted for 2 years or whatever. If those policies change, that affects the storage, and all of that, I think, points to the file having to be on the hub. So we're already putting a lot of work on the hub. Sorry, add files.
Hi, Rowan May. So first, I want to just say, we kind of risk it bike shedding here because this was the sort of least interesting of the PRs that we've got.
Yeah.
So one of the things that this group has been lacking, except during the interims, has been interaction on the lists. And so I would encourage you, if you have an opinion about this, to either post a response to this PR to the GitHub repo for the draft that Raphael mentioned. Please stick a link to that in the chat of this in the working group chat or on the mailing list. But I want to say as well, a lot of these choices we don't need to decide because they're going to be operational decisions of the providers. So if a HUD provider wants to say, sure, you can upload stuff, great. If they don't, they shouldn't have to. And it still works. So if you think that that is not true, then please go and either find me in the hallway or post on the PR. Thanks.
We need someone to store the data.
I'm going to close the queue on this topic in a minute. So if you're not in the queue and you want to be in the queue, then go ahead and get in. Travis.
Yeah, Travis from matrix.org. Just the obligatory Matrix already does all of this. We already have all the upload stuff, all the download stuff that we're kind of talking about here. Something to add to the considerations list for either the mailing list or the PR, whichever, would be basically just making sure that media is, or downloads, I guess, are linked to the messages themselves. So that way third parties from the conversations can't grab them. And then also just the authentication component that comes with that. As for whether or not it should be stored on follower or the hub, I'm more inclined to put it onto the follower myself, just because the hub is already doing quite a bit of work. And so it sounds like a pretty big commitment to for a service provider to do that.
Can I just ask a clarifying question? Because both of the last two speakers referenced this, like any server in the constellation could be a hub at any given time. It's not like there's services that are signing up for this, but they're like, I'm never going to be the hub. So I don't really understand this argument that much about like, we should put it on the follower because the hub's doing so much, because anyone who's participating in this has to be prepared to be a hub at certain times based on who starts the room. Or am I misunderstanding? Travis?
I think it's based off of, who starts the room, but if we put too much onto the hub, then, or into the hub's role, I guess, then the requirement on those service providers is that, well, if you want to start a conversation, you're signing up for potentially terabytes worth of data, which is that's a little harder to, I guess, reason about as a provider. Whereas if that sort of stuff is pushed out to the followers and then cached along the way potentially, then that's a little bit easier in that sort of respect. There's still certain things that the hub will have to do, and I don't think that there's really a way around that. But it is just like where do you put the 30 terabytes of like media that a relatively large conversation might generate?
But so that implies a service provider who the service that they offer is you can join other people's groups in the interoperable case, but you cannot create them because I don't ever want to be a hub.
Potentially, yeah. Like if there's too much for that one server to do, then those providers might just go like, well, the easiest way for me to be interoperable is to just never create rooms, which might be a legitimate strategy. It's just like, I guess, like whether or not that's a real concern might be an open question here. But I am a little worried about, just the hub doing too much.
Okay, I think we need to figure out if that's like a real requirement or not. Can you get in the queue?
Well, you asked a clarifying question to the last two speakers, so that would be Travis and I. There are clients that already do this where they store it on their local provider. So I don't think there's anything wrong with that. I don't think it breaks anything. So why would we be prescriptive about this? That's my.
Jonathan Hoyland, Cloudflare. This seems like something that doesn't need to be standardized at all, because reading the Mimi attachment draft, it's committed to by hash. The hash of the plain text is what's sent in the group. So even if it's the sender has to upload it every time somebody's trying to download it, it still works and makes sense and so we can just be like, whatever you want to do is fine, even if that's streamed from the sender. Like it works just fine. Like the security wise.
I mean, yeah, it's security wise, sure. Like throw it on IPFS, address it by hash.
But this is already addressed by hash, right? It's like.
No, I know, but I think the goal of this working group is also to enable functionality in addition to being secure. And I think making that functionality work requires a mechanism that people do.
In which case, just make it very, very general and say you can do whatever you like.
Ben Schwartz. So saying that the only authoritative source of the upload is the client device that uploaded it has a certain elegance, but as a practical matter means that if that device is not online, then you've lost your guarantee of being able to download the file. You've got files in the group, you click download, and it just doesn't work for some kind of mysterious reason. So I don't know. I mean, maybe we can paper over that with enough caching and it works. I'm not opposed to that, but it's not straightforward.
Sorry, we went out of order.
Yeah, Ben and Jonathan.
Sorry.
I'm Ben Go. I've been working on IPFS. I'm curious. It seems like it might be a good idea for there to be a data commitment on the ciphertext of the encrypted file. Is that already there, and if not, do you agree that it could be useful for like security reasons?
By data commit, you mean like a hash of the file?
Like a should that maybe you use RFC 9620 to generate that link or something. Yeah,
I mean, I think probably open the format. I think Hoyland was just saying that that's already in the draft Raphael mentioned. I'm not sure if it's in the PR or not, but that seems like a sensible thing to have. Yeah.
Jonathan, this is kind of an aside on the thing about the user, in a service that never creates rooms. I could imagine, say, a bot service where you invite some bot, that invites some bots to existing rooms, and so that's only ever, running rooms on other servers. But I don't think we need to do anything special for the architecture for that. If somebody chooses to write an implementation that can't be a hub, well, then they never not create rooms, but it's their problem, not ours.
All right, well, looking forward to some vigorous mailing list discussion on getting this driven down. All right, ready to move on to a more controversial topic? Next slide, please. Metadata privacy. It's one we love. So the core tension here is that on the one hand, like we would like to tell the servers as little as possible. If the server doesn't need to know something, we shouldn't expose the information to it. On the other hand, we want to have servers do stuff for us. I want to be able to ban someone and have the server forbid them from ever interacting with me ever again, right? The server needs to know something about who's in a room or who's trying to interact with me in order to enforce that policy for me. So we have this tension. We want to create some features that require servers to see some things, but we also want to manage the privacy of who's in there, things like who's in the room, and expose that to as few people as possible. And at a conceptual level, there's kind of three designs here. Really, we're talking about the proposals and the commits that are putting into effect operations in this group. So proposals to add and remove devices, proposals to change the participant list, to add and remove users, things like that. And so there's kind of three protection levels we can afford to that information. Right now, I think we're in state number 1, where these things are unencrypted. Anyone who's in the system can see them. Like it's all TLS, so the network can't see them. But like any server that's involved, any client that's involved in the room, they see all the MLS stuff. That's like maximal functionality, minimal privacy. On the other end, number 3 here, you could have schemes where only the clients see these things and they're encrypted so that none of the servers see any of the MLS information. That's what we have some drafts later on the agenda to address. The PRs we have open are trying to address kind of a middle case where the clients are allowed to see stuff. The hub is allowed to see stuff because it's in charge of enforcing policy. But the follower servers who are just there to route these control messages, they don't get to see things. So basically you end up with, I think Rowan's called it semi-private messages, where it's a message that's private to the clients in the group, but it's also exposed to just the hub server, right? So you just let the hub see these messages. You provide the hub the encryption key so it can read the messages so that it can do its job enforcing these policies. So it's kind of an intermediate between the maximal functionality, minimal privacy case we're in now, and the maximal privacy, challenging and functionalities, though I look forward to the drafts, case in number 3. So this is kind of the design space we're considering for a bunch of the rest of the time today. I think I'll probably defer discussion on this one to once we've seen those drafts, because I think it'll be a little more productive. But this is kind of just teeing up that, giving folks the conceptual framework to understand the overall space. Next slide, please. Yeah, and finally, the last thing we have open is an abuse reporting spec. So like obviously, lots of abuse happens in messaging, including IETF spaces. And so we want to be able to have providers be able to respond, to find out about that from users, to get reports of abusive messaging interactions, and take action on those. Now, as usual, the trick with end-to-end encrypted messaging services, the person you're reporting this to wants to verify that, like, you didn't just make this message up to screw over the person that you're reporting. So they want to verify that this is a message that that person actually sent and sent it through this messaging service. So Rowan wrote up this PR leveraging a bunch of existing art around franking, where you do some extra cryptography around these messages to add some proofs that the message came from the sender who's claimed and it transited the server. What's outlined on the slide here reflects not actually what's in the PR, but what Rowan and I discussed the other day. But the general idea is to take this franking design and import it into Mimi. So you get a little extra cryptographic proof to prove those properties so that you can have the foundation for reporting, and then you just have like an HTTP endpoint where you can report to the hub that things have gone wrong. I see Rowan moving, but no one in the queue. Deirdre in the queue. Travis. Oh. I think Travis got in first.
Yep.
Yeah, thanks.
Yeah, I guess it's just a question of why are we sending the reports to the hub and not the follower servers?
That's a great question. I would invite Rowan as the author of the PR to opine on that. I mean, at first blush, it seems like the hub is the one that's enforcing policy, so they're in the best position to take action.
So if the hub is responsible for the policy of the room, if the policy of the hub for this particular room is that you can't drop F-bombs, then it's the one that knows that policy, and there's no way that the follower server necessarily knows what that policy even is. So that was my motivation for sending the report to the hub. I mean, if you wanted to sort of a more generic way of reporting something to, abuse of the provider A by Alice at provider A of provider A's general terms of service, that's a totally different thing. And I think there was a comment by Travis actually on one of the PRs about maybe we need two different mechanisms. But I think the mechanism that people are, that I've heard from talks with providers, with existing providers, that they most care about is somebody violating the policies of the room, which would also include the general policies of the hub.
I would also note that franking design would get a lot more complicated if you had multiple potential reporting points.
Hi. There's been a series of future work building on asynchronous message franking since that was designed and delivered in, I think it was Facebook Messenger is the only major deployment.
I think so, yeah.
There's some work, one of the titles is Hecate, which is backwards and forwards privacy, different ways of reporting even in anonymous encrypted systems. Have we looked at that a little bit, or is it just sort of, no? Okay.
Yeah, I think the goal here is just to import whatever like the best art in the literature is, not to invent anything new.
And then I'm not even sure if they've looked at group management or tree ratchet or any of that stuff, but there's other work beyond franking that might be informative.
Yeah, that would be super helpful if you want to send a notes list. Thanks. All right, I think we've got a couple minutes left, and I think that's the end of my content. Okay. Next slide. Tim, is there a next slide?
No more slides.
All right.
You're free.
Tim, did you have something?
No, I was just going to turn to our next agenda item unless anybody has anything left they want to say about anything that Richard just walked us through.
Well, I guess I have one question, which is we have a parking lot in day 2. Do we want to come back around to the file download thing? Do we think we have more to talk about, or people want to kind of think about it and write some stuff to the list and then we can talk about it on Thursday?
There's a lot of traffic in the Zulip, I guess, about this, so it does seem like people have strong feelings.
Yes.
It also seems like something that's reasonably constrained and we might actually come to a conclusion on.
Right. Yes.
Oh, I'm going to say that we had lots of discussion on the mailing list and in PRs about the Mimi metadata stuff, and haven't had a chance to discuss this, in a sort of a larger meeting yet. Whereas the download stuff has had zero feedback on the mailing list, and so I think it would be maybe appropriate to allow that to have hallway discussions and mailing list traffic or comments on PRs first, and if we can make progress on this kind of pretty pivotal architectural decision about metadata privacy, which affects everything else in the protocol. And then if there's still room, then we can, if there's still time later, then we can continue to talk about download here afterwards.
Okay. Yeah. I mean, we have an hour for metadata privacy today, so maybe we'll come to a conclusion. But if not, we have more time on Thursday. Okay. I think, Rowan, you're next.
Yeah. For metadata privacy, we have content format. Wrong button.
Hello. Okay, so next slide, please. We're at draft 4 of the Mimi content document. So I did a draft 3 and then draft 4 in fairly rapid succession. We had a consensus that we were going to move forward with CBOR as a concrete binary encoding for the data structures that were in the Mimi content document. So here we go. So the document now has CBOR structs and it has a CDDL schema and example documents, and they validate with CDDL, and there's in the GitHub repo, there are all of the examples and in all of the various formats, and feel free to go and take a look at them and see what you think. The only other sort of main content change that I made was something that I planned to do in O2 and then just merely forgot. Basically wrote it down on the list of things to do and then crossed it off before I did it, which was to add a hash of the content to the external content array. And so that was actually something that people were discussing in the Zulip about whether the hash should be something on the ciphertext or the plain text. So feel free to chime in on an issue in the GitHub repo. I think that would be a very effective way to focus those conversations. Next slide, please. Okay, so there are a handful of issues. So we have 3 things which are related to different CBOR encoding choices we could make. And I was largely looking for input from that community to give input. They're fairly specific to knowledge of CBOR idioms. They don't really affect the function or the semantics of the content of the MIME content format. So that's those first 3 things there. And then we have 2 other issues. One is somebody proposed that we add a subject field. There was some discussion. I'm going to propose that we close this. If somebody wants to use a subject header or have something like that, and they want to do that via the existing extensions mechanism, there is like an extensions map. It doesn't require going to IANA. It doesn't require doing anything fancy. You can just go and use it. And the second, the last thing there is an issue related to matrix extensible events, which I think is no longer really relevant because of choices that were made in the protocol document. So those are the open issues. Would anyone like to comment on any of these? Hearing nothing. Let's go to the next slide, please. Oh, sorry. Hey, Travis, go ahead.
Yeah, just mentioning on the matrix extensible events. I think there's probably still a little bit more work to be explored there, but for now we can close the issue until particularly us on the matrix side get around to it.
Okay, thanks. Yeah, and opening in a more focused issue, a more specific issue is obviously welcome. So, okay, next slide, please. Okay, I had brought up this sort of nagging doubt about using an implicit message ID. And so I'm just going to kind of keep bringing this up until we have actual implementation confirmation that this works well for multiple implementers. So the content format uses a message ID, which is calculated from the hash of the ciphertext, and a timestamp, and its timestamp is chosen by the, no, that's not right. There is a timestamp when the message is received by the hub, which is conveyed in the response and is forwarded on to everybody else. However, because MIME is defined as a protocol for provider to provide, effectively a provider-provider interface with some requirements from the MLS and content perspective, we can't sort of force the client to server or the client to provider protocols to convey this timestamp. All right, so sorry, I'm just going to try to mute this here. Excuse me. It's really hard for me to read both of the copies of the slides. So for the purposes of abuse prevention and history sharing that is consensual history sharing, the party looking at a decrypted message doesn't have the ciphertext, and so they can't independently verify the message ID. There are a number of things that there are like some subtle things that seem like they could go wrong there, but I don't have like a concrete like this will definitely be bad if we do this. Deirdre.
What are the restrictions on the types of ciphertext formats that we're allowed to use in MLS? Because if we have determinism, which we may, or if we have caching, which we may have collisions for very popular memes that get thrown around because a news event just happened, and just by happenstance, we have colliding timestamps on the sender, the hub, and depending on the type of ciphertext that is being allowed to use, depending on how flexible that we're being about that sort of thing, we might have collisions there too.
Yeah, so this is always going to be an MLS private message, and then it's going to be the hash of that MLS private message. So I think we're pretty covered there, in that you could send the same meme several thousand times, and it's not going to give you the same ciphertext. The timestamp is the time that it is accepted by the hub, and so you can choose whatever granularity you would like at the hub to make sure that that is a unique timestamp. And actually, in fact, nothing does go wrong if the timestamp is the same for messages that arrive, basically at two different instances of the same cluster on the hub, for example.
Okay, so this is including a ton of other metadata, not just like haha.
Yeah. This isn't just haha. This isn't the Mimi content format containing a haha. This is the MLS private message, which has a generational ratchet and keys and nonces and reuse guards and all sorts of nice things there.
Okay.
So it's pretty safe, I think.
Okay, thank you.
This is Daniel Kahn-Gilmore. So it seems to me like you would not be able to send a message that refers to another message that you had already sent until you had heard back that it was accepted by the hub in this architecture.
That's true.
So if I'm composing messages in like an offline form, and then I connect and I want my client to flood those messages to the network, it can't actually have one of those messages refer to another message. I
can't reply. Yeah, I wouldn't be able to reply to myself.
That's right.
No, actually,
or send a message that like revises the previous message or anything until I've heard back from the hub, not just from my server, but until I could even hands up to the server.
And the reason
the server
is
has it
that
and is ready to deliver it, and I can't even send a follow-up that's like, whoops, no, I didn't mean that, with a reference until I've heard back from the hub that the hub has an ID.
And it's a little bit more subtle than that, because you can't actually encrypt to the group until you are connected again, because you don't know what the epic will be, and therefore you don't know what the epic secret is.
Okay, so I'm
while you were
staging these
offline,
messages not in the encrypted form that they'll go on the wire.
Yeah. So
Okay.
if you went offline at epic 12, and you were gone for an hour, when you come back, you could still be on epic 12, or you could be on epic 37, and there's no way of knowing that until you've downloaded the list of messages that are in that group.
Okay, and what happens when my server and the hub lose connectivity briefly?
I mean, nothing, unless you want it. I mean, what I'm not sure exactly what you mean. So
I'm sorry, I apologize. I don't.
This is actually very useful for people to understand.
So I am I'm now able to connect to my server.
You're able to connect to your server,
and I'm going to send a message that will go through to the hub via this CSSSC arrangement. And then, but my server and the hub server are, they've disagreed about something in the network and they can't talk at the moment.
Yeah, there was a BGP flap, say.
Right. And I've sent my message to my server.
Yeah. You will not get a response until the hub says
here it is. And so I can't even stage a second message to the server.
That's correct. Yeah. So
I mean,
you can
I'm someone who
hide
does a
this
lot of
user
offline
interface.
work, so and I'm fully aware that the network fails. So I'm just like trying to figure out what the consequences are operationally for that.
Yeah, you can hide this on the UI side. You can have a UI where you have the ability to go and do this, and you could even have a setting that says allow offline composition and automatic send. You could have an offline composition and then a confirmation. Are you still sure you want to send that given the after reconnect? Or you could have a strict, wait until.
But if my high
composition.
bandwidth time that I want to send
Mhm.
is during a time when my server is flapping its communication with the hub,
Mhm.
I can't make use of my connection to the server at this point because I have to wait for a response from the hub. Even if I've got a fat channel to my server at the moment, by the time I connect to the network again, I might not have the fat channel.
Yeah, if you want it, it's all about whether you want to encrypt to the current members of the group, right? Because while you're offline, while you're not connected to the hub, while you're not connected to the network at all, or while your provider is not connected to the hub, if the membership changes, then you would be encrypting to the wrong set of participants. Right. And that's the agreement is king or queen or is regal in MSF, in MLS.
I'm going to close the queue here in a minute. So if you want to be in the queue, please get in the queue. We're over time a little bit.
Raphael?
Yeah, I just wanted to speak to that really quickly because what DKG said, that's a really important point for folks to understand. It's indeed true that you need to have a good connection between your client and the hub via your server. So there's a strong requirement on that working well. We can be much more relaxed on the next section between the hub and the follower server. So that can be pretty much asynchronous, like it could be buffered. It's not entirely clear whether we'll have a push or a pull mechanism, I think. But fundamentally, we don't have a strong requirement for anything to be online in real time. But sending out messages, you somehow need to be able to reach the hub as a client.
Kevin.
So I think the point raised is very important of being able to respond to your messages, edit your messages. So maybe if we need a connection to the hub to send a message, we should actually enforce that. And if your server can't connect to the hub after, say, a timeout or something like that, it'll actually respond with an error and use your client's ability to resend. That way you don't get in the situation where you send a message when the hub is offline and then you go camping and this message that you accidentally typoed something, it's very offensive, gets sent and you have no ability to respond and correct yourself.
Yeah, so unfortunately that's out of scope because that's what you're talking about is behavior between the client and its provider, which is explicitly not covered by our charter or is excluded from our charter. But it's a good idea generally for implementers.
Yeah, maybe it is something that can be recommended or something.
Yeah, if we finish all of our milestones and nail it, knock it out of the park, then maybe we can extend and we can start doing some other stuff. That's it for me.
Thank you.
Thanks.
Brendan, you're up. No, we switched. Is that okay?
Okay, so I am going to talk to you today about a draft that I shared recently called the Robust and Privacy Preserving DS Proposal. It used to be just the Privacy Preserving DS Proposal, but now it's also robust because privacy is actually not the most important part. Spoiler. Next slide. So if you think about kind of in the abstract, what problems does Mimi need its DS to solve? One of the first ones is access control. So you want to make sure that only members of a group should be able to see and send messages. And you also want to be able to do spam and abuse filtering. So you want to prevent users from receiving or forcing the provider to store a bunch of abusive messages if someone sends a bunch of junk messages. You want to be able to just kind of like delete that and recognize them and not have them stick around and take up, disk space. Those are the two main ones. I mean, there's a lot of other ones, but focusing on those for now. The current approach that Mimi uses is the provider inspects commit messages, and it does that to learn and enforce and also sometimes try to modify the group membership. And of course, the problem there is the main obvious one is there's no membership privacy because you are requiring all of the handshake messages to be public. And also you can have this problem with invalid commits where because the DS or the server has relatively limited visibility into whether or not a commit is actually valid. So like the delivery service or the server can't verify the membership tag. It can't verify all the little encryptions are done correctly in an MLS commit. The provider can end up trying to enforce the acceptance of a broken commit where someone sends a commit with epoch 7. And so now the DS thinks epoch 7 is over and it's not going to accept any more messages to that. But really, this is not a good commit and nobody's able to process it. So the group is kind of stuck. And then there's also the pseudonyms proposal, which I think Conrad is going to present next, which does address the membership privacy issue, but it does it by adding some implementation baggage in terms of who can be added to a group and when, and also does the same issue with invalid commits. So Rowan. Okay, so going into what would be better than this. Next slide, please. So if we think about kind of in the abstract, what does an ideal MLS group look like? We have a series of epochs. So in this kind of diagram, each arrow is an epoch. And then the little dashes in the arrow, we use that to represent application messages. And then each epoch kind of perfectly ends with a little circle, which represents a commit. So each epoch has a single commit. That commit ends the epoch, and then you start a new epoch. And it's very fun and clean. In practice, though, that doesn't really work, or that's not kind of how it is in practice. So next slide. In reality, forks are kind of inevitable. So if you have an invalid commit that gets provided to you by the DS, the question is, what do you do? So one of the first kind of basic approaches is that you kind of just give up, like you see an invalid commit, and you're like, well, this group is kind of ruined now, so I'm going to go home. That is a solution, but it does unfortunately allow any malicious user to send such a commit and then DOS the group. Rowan.
Hey, so because the sort of title of this block of time is related to metadata privacy, I'd kind of like to have these discussions between invalid commits and metadata privacy a little bit separately and discuss the metadata privacy one first. I think that one of the things that you didn't mention on your first slide and didn't mention here is that it's possible if the DS is completely uninvolved, it's still possible to construct invalid commits where the DS has, doesn't get to see them at all. And this, the draft that you wrote and the Google Doc that's associated, the mailing list traffic, there have been no proposal for how to solve that problem. And so from my perspective, there's an invalid commit problem. There are ways that you can construct invalid commits, both in the case where the hub inspects messages and where it doesn't. And so I think we should first focus on the salient differences where we have metadata privacy differences between several approaches that have been proposed. What's in the draft right now with what's in the draft right now with pseudonyms, what's in the PRs that I proposed, what's in Me, and what's in your proposal. So we've got sort of a menu of possible things and talk about what those would give us and kind of have a talk about that first. Thanks.
Well, I would push back on the claim that there's not a solution to the invalid commit problem because that's what I'm currently presenting. But also, I mean, if you want me to like sit down and come back for a later block of time, I can do that. But this presentation is about invalid commits.
Okay. I was going to say, so for invalid commits, if the DS is paying no attention whatsoever, I could send a a remove request, or I could send an update, and I could manipulate the update path in a way that some users are in the new group and other users are borked. And we had this conversation on the list. You agreed. Your proposal doesn't solve that. So why is it better?
So there's kind of a hierarchy of different types of invalid commits. We have commits which are completely invalid, even to the DS. So the DS looks at it, it verifies it as much as it can, it verifies the signature, and it looks invalid to the DS. That's one type. Then the other type, or there's kind of a middle type, which is types of commits which look valid to the DS, but which nobody in the group can process. And then there's a third type of invalid commit, which look valid to the DS, but can only be processed by a subset of members, right? So what this draft doesn't address is how to handle invalid commits, which can only be processed by a subset of members. So only that one type. What this does address is how to handle invalid commits, which look valid to the DS, but can be processed by nobody. And then in terms of invalid commits, which also look invalid to the DS, we can kind of ignore those because we can say like, it doesn't matter, the DS can filter it or users can filter it, we can ignore it. Does that make sense?
Yeah, but I mean, I guess the question is that meaningful for Mimi? Do we have any evidence that this is a that like the number of ways in which you can do the last category versus the second to last and the last category is meaningful?
I think it's definitely meaningful because the last category where a commit can only be processed by a subset of members, that's one very specific way that a commit can become unprocessable, versus the second one, which is a commit which looks valid to the DS, but which no member in the group can process. There's 1,000 different ways you can do that. You can make the ciphertext incorrect. You can make the member tag incorrect.
I completely disagree that there is a meaningfully different sort of numerical difference of how many different ways you can do that. Basically, you can bork the tags. That's it.
Okay, but also the solution to address that. So if you have the subset issue, that's one specific way it can go wrong. You can invent a way to handle that one specific case. That's a lot easier than trying to do that same kind of thing for the second type of invalid commit where nobody can process it.
I don't see why that's different. You've got two different ways of breaking the group.
Let's hear from Conrad. Go ahead, Conrad.
Yeah, thanks. Could you clarify a bit, what is the threat model here? Are you worried about, and I think you talked about both at different times, are you worried about buggy clients? Then I agree there might be, there being more ways to break, the second to last kind of breakage with the second to last invalid commit. I would agree that, sure, there's more ways to have bugs that cause these invalid commits. But if you talk about like a malicious user, surely whatever works the malicious user will do. So kind of excluding the second to last category is not super meaningful because the malicious user will always then, just use the last one that's still possible. Could you speak on that a bit?
So the threat model here that we're concerned about is how to handle both a malicious DS and how to handle malicious users. Because the DS can be malicious, but also so can the users. And you want to prevent against both of those.
Okay, fair enough. Then I have to say I second Rohan in that I don't really understand I don't think there's a meaningful difference between the second to last and the last category. Yeah, sorry, just my 2 cents.
Okay, so to go back, in the case where we're in a group and we're reading messages from the group and we said that the DS has provided us with an invalid commit, the question is, what do we do in this case? One solution is you can give up and you can just kind of go home and say the group is broken. That as a solution, but it's unfortunate and it allows any malicious user to DOS a group. So next slide. A second approach is to externally rejoin the group. So basically you accept that this is the commit, which is the epoch. I just can't process it and I have to do something about that. So in that case, I would leave the group and then externally rejoin at the most recent epoch. And we kind of unpacked this for a very long time in the MLS working group yesterday. But this introduces a lot of really difficult security concerns that we don't have any concrete way to actually address or handle. And actually, it also has the same issue as the last one, which is it still allows malicious users to DOS the group. Next slide. So then the third option, when you receive an invalid commit from the DS, is you could ignore it. And this is actually the same thing that you would do with any other invalid packet in basically any other protocol. So if you receive an invalid application message from the Mimi server, you would kind of just throw it away. You wouldn't like do anything special because of it. Also, like if you are a TLS client and you receive an invalid packet from the server, you would also just throw that away. You wouldn't do anything special with it. So that's nice because it aligns a lot more closely with the actual provable security guarantees of MLS. So it doesn't have any kind of security concerns from just ignoring messages you can't process. And it also doesn't introduce the DOS concerns that the other two approaches have. Next slide. Of course, the problem with potentially ignoring some commits and accepting others is that that creates the possibility for forks, where multiple users send commits at the same time and they have different ideas about which commit they should accept. So in this diagram, we have an epoch where we have several commits which have been sent to it, and only one of them is actually valid, and only one of them is actually valid in the eyes of the user, but to the DS, it just sees several commits, and it sees several different epochs branching out from each of those commits. So that's what we have to figure out how to handle in the proposal that I write. So next slide. The way that we can handle this is we can put each of these kind of forked epochs of the group into a box, essentially, which is a way to pass it around on the server. So in each of these boxes, we have a single epoch, and then within each of these epochs, within each of these boxes, all of the messages are kept in a linear order. So within each box, all of the messages are in a consistent linear order. But what's important is that there is no order between each of the boxes. So they all kind of exist in space, and the DS doesn't really infer a relationship between them. It just keeps all of them, and it keeps all of the messages in each box in that order. So next slide. How do you actually make this usable for processing a group? What you have to do is you have to give each box a unique ID so that you can address it. And then that ID is what's used to read and write the messages to each box. So if you're just starting a group, you might start with like box A, and you read all the messages in that epoch, and then you get to box B, which is the next one. And then you can see each commit in box B has an implicit relationship to all of the subsequent boxes that follow it. And you can kind of traverse that relationship to follow basically different paths through the branches. Yeah, and of course, the reason that you can't just address them by epoch number anymore. Like if B is epoch 7, you can't just say, I want to send a message to epoch 8, because there are multiple epoch 8s, which are all like D, C, and E. So next slide. To kind of work through an example of actually reading messages in this model. So if, like I said, if we just join a group and we're in epoch, or we're in box A, we read all of the messages in that, we find the first commit that we like, that we think is valid. We take that commit and we process it, and we move on to epoch B, or to box B, which is the next epoch. We process all of those messages. We come across the first two commits in box B, which are invalid for some reason. Maybe they have proposals that we don't like. Maybe they violate the group policy. Maybe they're just cryptographically invalid. So we just ignore them, which is what I said we would do. And then we get to the next we get to the first valid commit, and we process that. And that takes us to box C, and then we continue that. So that's how we would read messages through a series of epochs in the group. Next slide. So to kind of understand how access control works in this context, like we said before, the ID of each box is what we use to read and write the messages to each specific box. And the way that we compute that ID is actually that we derive it from the MLS key schedule. And the consequence of that is that you can only derive the box ID if you're actually in the group at that epoch. And as a consequence, only members that are actually in the group are able to compute the box ID. They're the only ones that are able to send and receive messages to that group. Because if you are removed from the group in some commit, then you're not going to be able to process it. You're not going to have the key schedule for the next epoch of the group. And you're not going to be able to compute the box ID, and you're not going to be able to send or receive messages to the subsequent epoch, and you're going to be locked out. So that's how that works. Next slide. So to really talk about why this helps with invalid commits, because we allow these different branches of the group to exist, users can choose to follow these branches if they actually want to process that commit. But in practice, users are going to choose one commit for each epoch, and they are going to process that, and they're going to follow basically a linear series of epochs through all of the branches, which means that all of the branches that correspond to invalid commits, users are never going to actually access. Next slide. So, and then why does this help with spam filtering or spam deletion? Because when users send invalid commits, they create a fork. Like we said, any user that isn't actually interested in that fork isn't gonna, follow that path. They're not gonna download that box of messages, and they're never gonna access those boxes. And of course, the hub can actually see that through traffic analysis. The hub can see that, some user sent a commit, they created box D, and they never sent any messages to it, and no one else ever requested box D. So that seems sort of reasonable to conclude that that was a spam message and that nobody's actually interested in that. So we can go back and delete that later. Next slide. So to actually get to the privacy part, like I said, this is not really related to privacy. It's more so related to how can the delivery service not have a prescriptive view of the commit messages that get sent to an MLS group. And of course, when the delivery service doesn't actually need to inspect commit messages, you can encrypt them. And if handshake messages are encrypted in MLS, that restricts the visibility that each participant has into what's in the group. So if you look at this diagram, if we start with the hub holds all of the messages for the group. The only thing that the hub can see about the group is the blue arrows that are going directly into the hub. So the hub can see that its own users A and B, are interested in participating in this group. So then the hub knows that those users are probably in this group. And the hub also knows that, remote service provider 1 and 2 are interested in this group, but it doesn't actually see anything about user 1 or 2, about the users of each remote service provider. It just sees sort of aggregate data from each remote service provider in the case that handshake messages are encrypted. Next slide. So also it was brought up on the list that because you have to process each box one at a time and you kind of have to follow a series of jumps through each box, you have to fully process one box and process the commit to compute the box ID to download the next box. That could potentially create a lot of round trips where, if a user has been offline for a long time, then they come online, it could be a lot of round trips to actually go through and get to the most recent state of the group. Rowan?
Okay. So in slide 10, you show a fork. And so it's unclear to me how you pick which. So here you've got the hash of A is B, and then the hash of B refers to C, or does it refer to D or E? Like, how does that work? Why does the hash of B refer to C and not D or E in the slide you were just on?
So each box has a unique ID, and that ID is computed as a secret, which is exported from the MLS key schedule in the epoch that the box represents. So in this case, B represents a secret, which is exported from the key schedule in the epoch for whatever message.
Yep, got it.
Yeah.
So in the picture that you just showed, I think slide 15.
Right.
So you said, so in answer to a concern that I had about excessive round trips, so slide 15, I think it was, the slide we were just on.
Tim.
So thank you. So how does this, so either the requester is asking for the hash of a box ID, or it's not, right?
Okay, so let me talk through this. So, like I said, because you have to kind of jump through different, a series of boxes to get to the most recent state of the group. If a service provider is confident, because it's interacted with other users, that some series of epochs are going to be requested one after the other, you can provide them proactively. So if a user requests, box A, and you're pretty sure that the next thing they're going to request after they finish processing A is B, you can provide box B.
And how does it know that? Because it can't calculate the actual box ID.
No, it can't calculate it, but it does, interact with users who participate in the group. So whenever someone sends a commit to box A, they also tell the server, the next box that I want to create is called box B. And so if there's only one commit sent to box A, the logical conclusion is that the next box that the person is going to want is box B.
So in other words, what you're saying is if there are no forks, that this proceeds normally, but if there is a fork, you can still access the correct, from the client's perspective, the correct fork.
Yes. Right. So the way to think about this is kind of like an HTTP2 push. So when a user requests one thing and you're pretty sure that they're going to want other things, you can kind of provide the other things that they may want proactively. And it's not like a requirement that the user actually go through and process all of these things. Like you don't have to actually 100% know that this is the next thing the user is going to want and they're absolutely going to request it and you're going to force them to process it. You can just provide it. And if they actually end up wanting it, it's already there. The only sort of caveat is that you have to hash the box ID for boxes that haven't actually been requested yet. And that is to avoid leaking box IDs that the user might not actually know. Because if the user was removed in one of these boxes, in one of the commits in one of these boxes, they're not going to be able to keep processing in the group. But if the handshake messages are encrypted, you won't know that. So that's why you have to do that. Bingo.
Just a clarifying question about that. Can we look at slide 10 again? I want to make sure I understand the answer. And I think what you're saying is that basically like in B, there's basically like B prime and B double prime, like the different perspectives on B from different clients, depending on whether they treated those commits as invalid or not. Like, and so there's different clients that treat some of those commits as invalid will have like different perspectives of what B is, and therefore follow this exported key schedule link to different boxes.
Exactly, yeah. This kind of accepts the possibility that some users will have a different view of what the valid commit for each epoch is, like they'll have a different idea of which commit they want to process and then which box they want to go to after they finish processing B. Of course, the catch is that all of the honest, correctly implemented clients will always choose the same commit to process. So all of the honest, correctly implemented clients will always stay together and always follow the same commit. The only people that branch off and actually follow other branches are people that are either malicious or buggy.
I understand. Thank you.
Okay. And I think that that last slide was actually my last one. Yep.
We have about 2 minutes before we're supposed to move on, so please keep it brief.
Yeah, so I just wanted to confirm, like in this functionality privacy trade-off here, it seems like in this scheme, the only thing that the server does is apply access control based on these box IDs. So you can't do something like have the server enforce a ban or have the server facilitate a join of a new device. Because if you're going to do that, you'd have to distribute a group info, which would leak a bunch of stuff. Is that a correct assessment of what the server can do here?
So the first part where you said the server can't help assist a ban, that is correct. So in this model, all of the policy enforcement is on clients. Clients have to enforce all the policy. So if you see a commit which adds someone that you think is banned, what that means is that you would ignore that commit and you wouldn't process it and you wouldn't go down the fork where that user has been added to the group. The second part you said, which is that the user can't, or that the server can't facilitate an external join, that's actually not true. Because in this model, this is indifferent to whether or not handshake messages are encrypted or not. You can encrypt them or you cannot. And if you don't encrypt them, then you can support external joins still, and you can do that.
Okay, sure. Anyway, question for the group, just for folks to consider is like, given that summary of the functionality, is that a good trade-off for the group to adopt?
Yeah, I'll try to be brief. And I guess Conrad is also going to touch on that and what Richard just asked. But maybe maybe you can give us one example. Say I have exactly one client, one phone, and I want things to be private. So I want to have encrypted handshake messages. And now I have a bit flip on my device. So the consequence of that with MLS, of course, is that I cannot really decrypt messages. But on top of that, I can also not even go fetch them from the server because I cannot calculate box IDs anymore. What are my options as a user?
You asked what is your option for doing external rejoins if you don't know the box ID?
Well, I mean, let's just say I have a bit flip on my device, right? I'm in a group chat, and now I don't receive messages anymore because I cannot even go fetch them. Like it goes silent, but somehow I know that cannot be right. But what are my in practical terms, what are my options? To get out of that mess, essentially.
Sorry, Raphael, can you just repeat the last thing, the last sentence? What are your options?
So yeah, sorry. So my question was about the user experience here. I have a phone, like it's a single client. I'm in a group and I have a bit flip in the state that is on my device. So the immediate effect of that is that I cannot no longer decrypt messages, and that's always true for MLS. But on top of that, I can also not fetch new messages because I can no longer calculate the box IDs. And my question was, from a user's perspective, in terms of user experience, what are my options to get back into that group again?
Got it. Okay, sorry. So your options there, if your state are compromised or if your state is corrupted, you would just do an external rejoin to the group and you would join the most recent version of the group, which you can still do. You can send an external commit with the group info and not know the box ID and just have the delivery service add your external commit to the most recent box. So you don't have to know the box ID. The DS can do that for you without knowing that.
But we want to use encrypted handshake messages, right, for privacy reasons. I mean, that's the whole purpose here of doing that. So where does the how does the external join work? Like in very practical terms, how does the server know the ratchet tree, etc.?
Well, if you have encrypted handshake messages, then you can't support external joins.
So essentially, it comes down to having a choice in that particular situation between having metadata privacy or having that functionality, right?
I think so, yeah. I mean, it's possible to make a new extension that maybe helps that case. But right now, yes, that would be the trade-off.
So this is what the entire next presentation is about. So do we need to go?
Yeah.
Could we move on to it?
Well, I'm just going to add a variation on what Raphael said, which is even if it was public message and there are multiple forks, how does the DS know which fork to give when it's asked for the group info?
Well, it's dealer's choice, essentially.
So in other words, you have indeterministic behavior. Non-deterministic behavior. I'm sure implementers will love that. Thank you.
Okay, thank you very much. Conrad, you're up.
Okay, thanks. Yeah, so on the last meeting, I promised to, since we had these two competing metadata conserving approaches, on the one hand, we had encrypted handshake messages, on the other hand, we had the pseudonym-based approach to go over the Mimi features or the features that we talked about in the past and see which of the features works or doesn't work with which of the approaches. 2 caveats right off the bat. I just realized that when exporting slides from Google Slides, you also get, as a PDF, you also get the kind of slides that you chose not to show. So there's we might have to skip a few slides. And also, I think it's worth, and I didn't do that, it's worth differentiating, as Brendan also pointed out, that we have we can do encrypted handshake messages, and we can do pseudonyms, and then in addition we can use this kind of this approach to handling invalid commit messages that Brendan just proposed with this you know, I don't know, how do we call this approach? Would be good to have a name for it. Brendan, do you have an idea what to call it? The boxy approach kind of thing, which the box approach. Okay, for now. So we have this box approach that we could use both with, you know, both with the baseline MIMI protocol that we have right now, where we use user identities and there's no metadata direction. We could use it with a pseudonym-based approach, and we could also use it with the encrypted handshake approach. And yeah, in these slides, I haven't really differentiated between the handshake approach, encrypted handshake messages approach, with the box epoch thing, and I haven't looked at them independently. So I'll try to break that down when I get to the slides. Okay, let's get started. Finally, next slide, please. Okay, so just to kind of start by looking at the approaches, and I want to roughly kind of say how they protect metadata, or which parts of the metadata they protect. So starting on the left, we have the baseline, which is MIMI protocol right now. It leaks where every message leaks the group ID, it leaks the epoch. If the hub keeps track of the hub can keep track of the group state, so it leaks the identity of group members to the hub. It leaks the identity of senders of messages. It leaks group operations. If a sender does an add or remove, you know, the hub sees all of that. So that's kind of the baseline that we have right now in terms of metadata protection. It's not great. So then kind of as a next step, there's this MIMI approach, which is the pseudonym-based approach. Still leaks the group ID with every message, still leaks the epoch, but now it only leaks the per group pseudonyms of members. It only leaks the per group pseudonyms of message senders, and it only leaks pseudonyms group operations. So the hub can still see what kind of if there's an add operation or remove operation, but it cannot really see which real identity is targeted. It can only see the pseudonyms. And then finally, there's the encrypted handshake messages approach, which with every message really only leaks the group ID, and it leaks the epochs. And Ron, you just give me 1 second. I didn't differentiate here between, I'm saying it leaks to the hub, and depending on if you use the semi-private message that you proposed, it might also leak to the followers or not, but we might get to that later a bit. So there's a bit of nuance depending on how you use it exactly.
Yeah, that's all I was going to say, is that under baseline here, that actually you could sort of split it out into a sort of 2 or 3 different variations, where you can use pseudonyms with baseline, which is baseline is basically what's in the draft now. Baseline with pseudonyms is mentioned as an option in the draft, and then semi-private messages is listed as a PR off of the MIMI protocol, which leaks the identity of the pseudonyms to the hub, right? So there's like a nice spectrum there. Thanks.
Yeah, if you go to the next slide, we can actually see the spectrum, I think. Yeah, so this is the taxonomy. Ron, thanks for the feedback on the slides at this point. So this is, I think Richard kind of proposed this way of splitting up the metadata privacy tiers. Just to go over it again, because I think it's important we know what we're talking about. So based on this, hub and followers can see everything. Then the second one is the essentially baseline with pseudonyms, as Ron just said, where everyone just sees pseudonyms instead of real user identities. Then the third one is the same as 2, but now messages are additionally encrypted to the hub so that everything is hidden from the followers, and the followers cannot essentially see anything except for the epoch and the group ID. And then the fourth is that we kind of extend this encryption to not just the followers, but also the hub. So it's a kind of graded approach here. Okay, next slide, please. Thanks. And so this is kind of what I wanted to go into detail a little bit about, and then maybe we can have a discussion about kind of functionality and what we want in terms of compromises between metadata privacy on the one hand and kind of the functionality on the other hand, what kind of features we want and stuff. So go through it again. So in the baseline, we have both push and pull architectures, and by that I mean the hub could push to the followers, but the followers could also pull messages from the hub. Essentially, both might work. I don't think we've decided on any one of those. And also in the baseline approach, it allows server-assisted external join. That's because the hub can actually track the group state. And if someone comes and wants to rejoin the group for whatever reason, or join the group for some reason, the hub can provide a group info, can provide a ratchet tree, and help that client actually join the group without any intervention from an existing group member. And then thirdly, we can enforce any sort of policy on the hub because the hub can see all of the messages. Then kind of going one gradient up to the pseudonym-based approach, it's essentially the same as with baseline. You can do push and pull architectures. You can still do server-assisted external join. There's a slight caveat because the hub doesn't know the real identities. And so if a new client comes in and wants to join the group, the new joiner has to somehow learn the mapping between the pseudonyms and the real user identities so they can actually know who's in the group. And since we encrypt that, so the hub doesn't know it, the new joiner needs some sort of key material. And so there needs to be some sort of involvement of an actual member of the group. It's not like, again, it allows the assisted join, but again, you need some sort of key material in addition. And then finally, in the pseudonym-based approach, there is a way to enforce policy, at least partially, given that the hub cannot see the real identity of the members. So as we'll learn in a couple of slides, for example, a ban cannot really be enforced on the hub because the hub doesn't really see who's trying to join the group. And then finally, getting to the very right, the encrypted handshake messages approach. And here I wrote it requires a pull architecture or a subscription-based architecture. That's because I assumed that with the encrypted handshake messages approach, we're also using the kind of boxy epoch thing, which doesn't really allow you to push out because the server has no idea who's actually in the group, and it needs the followers to go and fetch the messages for the users or the followers that the followers know are interested in the messages from the group. And then finally, as we just discussed, that Raphael noted and Ron noted that there's no server-assisted external join possible if you encrypt handshake messages, because the hub cannot keep track of the group state and not help new clients actually join the group because it doesn't have the necessary information. And finally, there's no policy enforcement on the hub because the hub doesn't really see what's in the messages and who's adding whom or who's removing whom and that kind of stuff. Okay, next slide, please. And I think we have to skip the next one. Yeah, skip that one, please. That was not great at visualizing stuff. Right, so I looked at a couple of features. Those are taken from the spreadsheet. I'm afraid to say I can't remember who compiled it, but it went around the Mimi list.
Yeah, the Matrix
Okay.
team. Yeah.
Okay, thanks. So yeah, this is thanks to the Matrix team who compiled this list of, they went to the kind of DMA gatekeepers and looked what kind of features they would support. And so I went through these features and tried to see if we can still support those if we have one of these two metadata reducing approaches. And so just to list them real quick, there's direct invites. So a user invites another user to a group. Then there's invite codes, where a user creates some sort of code that allows another user to join the group. But in this case, in contrast to the direct invite, the user who creates the code doesn't necessarily know in advance who is going to use that code to join the group. Then there's third-party invites, which is kind of a variant of invite codes, where the invited user could also be someone from another platform. This, I think, appears mostly as kind of guest rooms in current gatekeeper platforms. But yeah, not super sure about that. Then there's the ban, so that users can ban other users, and then somehow it's enforced that that user cannot rejoin the group. Users can kick other users out of the group. Next slide, please. Rowan, yeah.
Yeah, I just wanted to mention that I think it is a pretty strong requirement for the larger providers to be able to not just have a user ban someone from a member ban a user from their group, but also to be able to have the hub provider say, I've seen enough reported abuse that I want to ban this user in all groups and I want to remove them from all groups. I think that's a really critical requirement. And we need this solution to, we need the Mimi solution to be able to do that, or we need to come up with a reason why we can get similar strong abuse prevention without that. Thanks.
Thanks, Ron.
Yeah, thanks.
We'll let Conrad get through to the end, but if people disagree with that, it would be really useful. Like, today's the day to state your disagreement. So.
Right. I mean, this was kind of the purpose of this of these slides, to kind of elicit, make people come up front and say what kind of features they want and they think it's important. So thanks. Yeah. So just go through the rest. Limit who can post and send. So this is essentially allowing users to mute one another. Then edit, delete other users' posts. Kind of self-explanatory. Access control, there were a bunch of features that I just decided to group under access control. You can look at the sheet to go into details, but I think for the purpose of metadata, of looking at the approaches and what you can do with them, I think access control is a good catch-all term. Yeah, Benjamin.
Ben Schwartz. I'm sure you all have had this conversation a million times, but the idea that for abuse prevention, you need the hub needs the ability to identify individual users of third-party platforms and selectively ban them is fascinating, at least, and a little scary, more than a little. It changes the nature of the relationships here significantly, where instead of the providers having relationships with other providers and their own users, now the providers have relationships with the other providers' users as well. And potentially, as a provider, I need to have opinions about the individual users of other providers, which is a very strange concept because I have no idea how their account mechanism works. I don't know if this collection of handles associated with some other provider actually represents one user or a credit card or a postal address, or like what the account creation restrictions are, what their rate limits are these ephemeral accounts that on and on. Also, it raises a bunch of really interesting policy questions. Like, if I have this ability to create this kind of access control, then do I incur a responsibility to exercise this access control? I think as a provider, I would actually feel more comfortable if I had no technical capacity for that and could very cleanly say to anybody who came along, that's not my user, go talk to their provider.
Just a quick response to that. If you're a hub provider and you have a policy that if you have a group for discussion on some topic, and the policy of the group is that you're not going to share pornographic material, that's perfectly legal and it might be accepted on the hub on a different room. But if you have a user who keeps who does that maybe repeatedly, to say that the hub has no ability to remove that user from other rooms in their on their system, I think that's I think that's a perfectly reasonable thing to do. We're not talking about saying you have to go delete this user in other rooms on other hubs.
So I think there is a version of this that maintains the CSSSC architecture, right? Where essentially I file an abuse report back to that provider. So this user appears to be misbehaving. I really don't want to do business with this user anymore. That I think maintains the separation and potentially allows that provider to think about things like whether there's a cluster of abusive accounts here that it can identify because it has much more metadata than I do.
So I would invite you to go and comment on the PRs, or to write a draft, or to come see any of us that have been involved as authors in the hallway.
Okay. Ben, do you want to respond? You're still in the queue, or do we defer this discussion to the mailing list and the PRs?
I think Ben is out of the queue.
Okay. So yeah, there's only 10 minutes left. I really like this discussion. So I'm not sure how we should proceed. We can defer the discussion, but I'm happy to have it here since I have a couple more slides, but questions. Yeah.
I mean,
okay. Anyway,
we really do want to get to the end point where we kind of make a decision, or have at least a sense of the room about how people feel about the different options. So we have more time that we could use for that on Thursday. So if you'd rather do that, we can do that. But the point of this week is to start taking some options off the table here. So.
Okay, then I'll try to get through the slides, and maybe we can either have the discussion then in the last few minutes or in the next meeting. Okay, so just to close on that, there's access control, kind of general term here. There's auditorium rooms where users can only see or identify a subset of other group members. And then there's kind of a means of limiting who can send what types of messages. It's essentially boils down to the same as access control. So next slide, please. Right. So yeah, I tried to color code here in terms of on the left we have the different features, and on the right we have the two approaches, me and encrypted handshake messages. And I encoded green where I think it's really not an issue, and red where it's an issue, or at least it's an issue to do it on the hub. So for example, invite codes would require this external join feature, which is essentially, as far as I'm aware, not really possible with encrypted handshake messages. So that's a no. And then we have, in this case, the invite code with me, I think should be possible, even though you need the key material to for the new client to identify the group members. You just embed that in the link, and then invite codes should work with the pseudonym-based approach. So kick should work in both cases. Ban, as I said, is tricky to enforce, and we can have this discussion later, but maybe if you have abuse reporting involved, then the reporter of the abuse could actually, reveal the actual identity and de-pseudonymize the offending party or something along those lines. So I'm confident we can make something work there. With encrypted handshake messages, I'm less confident, but yeah, don't want to go too much into specifics. Next slide, please. Again, with the features on the left side, this is mostly about access control or visibility in the group with the auditorium. And the main issue here with the encrypted handshake messages is again that the hub cannot really enforce any of this or be a part of any of this because it doesn't really see the messages. And whereas in the pseudonym-based approach, it's possible because you can, for example, assign roles to pseudonyms, and then you can use it, you can do access control just like you would do normal role-based access control. Next slide, please. And I think now you can essentially skip more or less until the end. I think these slides are just draft stuff. Yeah. So can you go back one slide? Maybe there was, yeah, okay. There's a brief summary. So both approaches limit metadata leakage. Clearly a kind of ingredients, Mimimi to a lesser degree using the pseudonyms, encrypted handshake messages are really good. They almost completely get rid of the metadata. Then, and both approaches limit the hub capability to enforce policy. Encrypted handshake messages make it pretty much impossible. Mimimi still allows it to a certain degree because the hub can see the pseudonyms. And then both approaches also kind of limit the capability to perform server-assisted external joins. Again, encrypted handshake messages kind of don't really allow that. And Mimimi does require this additional key material to de-pseudonymize the group members for new joiners. And then the last point about restricting to a poll/subscribe model, that applies to encrypted handshake messages, but it generally applies to this kind of boxed epoch kind of approach if we in the end want to use that to mitigate invalid commits. Of course, you could use that for the Mimimi or the baseline approach as well. And yeah, that's pretty much all I wanted to say. Give a brief overview, kind of give everyone a feel for how the individual approaches kind of limit what we can do. And yeah, want to encourage folks to come out with features that they think we should really have, such as banning, or Rohan mentioned, for example, being able to, if an account that gets deleted, being able to evict that deleted user from all of the groups they're in. And yeah, maybe we can discuss those and see how important those are for this limited metadata leakage approach.
Thanks.
Also, maybe note, sorry, one last thing as part of the discussion. I think last time we also agreed that we might want to have two modes. So we could have like a baseline mode for Mimi, which can do essentially everything. Then we have an additional kind of limited metadata mode, which can only do a subset of the functionality, but is better at hiding metadata. Just to kind of keep that in mind, that there might be two modes that providers can opt into or not.
Yes, so that's actually, I think, where I was going, which was, I think the sense that I've gotten from past discussions is that people want to have the two modes. So we would have a baseline mode, which would look approximately like it does now, and then we'd have a limited metadata mode. And we've been talking a lot about which approach we should take for the limited metadata mode. But maybe we can talk a little bit about that today, and then on Thursday we can come back and allocate time to talk about the choices within the limited metadata mode.
So having the two modes is probably going to make a lot of sense, and I agree with that. But it does seem to have been the trend over time. What a baseline mode looks like, though, should probably be open for discussion. Okay. Because one thing I noticed here, as we're talking, obviously Mimi is about using MLS, and not to extrapolate this further, but as noted in the MLS working group, the baseline for MLS was Signal. And if we're talking about leaking more metadata than Signal, then we're actually overall reducing the security that we're providing. So what that baseline should look like and how we can minimize it while providing the net functionality that everyone wants as the kind of simple version, and then having the more secure version probably makes a lot of sense. But we do want probably a decent minimum bound there versus the mass metadata leakage overall.
And can you, if you have an opinion right now, say, do the per group pseudonyms as the baseline meet kind of what you're thinking, or is there some other option that you prefer?
Great question. So not to make you hate me, but so there is actually a somewhat third option among these that have been discussed, or fourth option. So we have the pseudonym approach, obviously. We have this encrypted handshake, which is meant to keep everything out of the hub's hands. We also have a version here where we use the semi-private messages that I think Rowan has a draft for, and use that to encrypt to the hub, the handshake. So it's available to the hub, but also not available as a mass metadata leakage. And then there's like two subversions of that if we really want to have fun, where we can use that with a pseudonym approach and then have pseudonyms available to the hub, but not again mass on the wire. Now that just expands our space of options here. And as I said, it's going to make you hate me. But there's a lot of variabilities here. I would say, as a personal view, having a pseudonym approach or sort of encrypted handshake approach would be the minimum bound, so that there isn't stuff outside of what the hub can see.
Thanks. Ron.
Yeah, so I mean, just to be clear, my proposal has been that using the choice is kind of available to the clients if they want to use semi-private or public, and if they want to use a pseudonym in a particular room. But if you wanted to make it simple, you could make the recommendation, just use it per group pseudonym unless the user takes explicit action to say, no, I want to be correlated with, some specific permanent identifier.
So don't walk away, come back. So in the case where you leave it up to the client, then our quote unquote baseline doesn't have any of these metadata limiting features.
The baseline is that the hub has to support the semi-private message, and it like basically as written in the protocol, it works fine with pseudonyms. So it needs to continue to work fine with pseudonyms.
Right, but what I'm saying is that what it sounds like to me is that the debate is, can a client or can a service choose on behalf of its clients that it's using this baseline that doesn't take advantage of semi-private messages or pseudonyms?
I mean, I think what we're talking about is like basically a mandatory to implement kind of level thing. Is that kind of what you're talking about?
Well, this is what I was trying to elicit. Is like, are these things mandatory to implement, or is one of them mandatory to use at a minimum?
I actually don't have a strong opinion on that.
Okay.
I think we definitely need mandatory to implement.
Okay. Conrad and then Raphael, and we're over time. So.
Yeah, I in principle, I like the idea of having this hybrid mode where clients can decide or providers can decide what they allow in terms of, a pseudonym-based approach or a real identity-based approach. I'm just going to say, like, even if you make that optional, the pseudonym-based approach, you still need kind of the machinery that the pseudonym-based approach needs in terms of, de-pseudonymizing folks and having these kind of functional oddities around there. So I'm not sure that's really what we want in the end, but yeah, just wanted to note that.
Oh yeah, very quick final note. Going back to what Ron said, I think the semi-private messages, it's still a great concept. It's somewhat orthogonal to the pseudonyms. And unless we run into some very specific problems, I think we should make that the baseline for sure. Personally, I'd also be inclined to say we should use pseudonyms as the baseline, and then see how we can solve some of the problems we still have. Like if ban really is something we need to address, then we need to find a solution for that. But going back to what Britta said, I'm all for raising the bar for the baseline.
Great, thank you. Okay, we'll kind of figure out how to structure the rest of this discussion on Thursday. So thank you, Conrad, and thanks everyone. See you back on Thursday. Thanks, Tim.
Here.